All right, guys. Slot method, unit 2, activity 1. Hopefully the test went well for you. What I'm going to do is work my way through the note here. We'll see how many videos this takes. Should be too many, but I don't want the videos to be too long, so I might cut them off after a couple minutes and then start another one. So the first thing we're going to look at here is the slot method. So let's go back and talk about the fundamental counting principle. So if we have, that's what we use obviously for counting. So what we're going to do is, give me a second here. If we have a tree with numerous branches, so let's say we were looking at like a password or something, and there were 10 options we're using numbers. There are 10 options for the first branch, for the first number, and then 10 more for the next one, et cetera, et cetera, et cetera. And let's say we had a pin with 4 digits. So you have 10, 10, 10. Those are your options for the password. So what you would do is draw a tree, and then after each branch, at each node, you would just extend that, and you would note that this would be a giant tree. There's going to be a different way to do this without drawing trees. So what we do is we do something called the slot method. So if I was to do this, what I actually do is I put little slots here. And when I solve a problem, you put the number of slots for the number of potential variables here. So if I'm doing a password, a PIN, right, for your phone, and you have 4-digit PIN, and you want to know how many different numbers you can use, what you do is you say to yourself, how many numbers can go in the first spot? Well, there's 10, right? And then there's 10 for the second spot, and 10 for the third, and 10 for the fourth. One thing you have to ask yourself for these questions is, am I allowed to repeat the number? And for passwords, you are, right? You could have a password of 1111 or whatever, 1231. So you can repeat the 1 or not. It's up to you. But you have the option of 10 and 10 and 10 and 10. And what happens here is when you have the numbers like this in the slot, what you do is you just multiply these numbers across. So it'll be 10 times 10 times 10 times 10, which is 10,000. So there's 10,000 different options for your password. You're always going to multiply. Sometimes in math, what we do is, I don't know if you've seen this or not before, but because the x, I don't know who came up with this idea, but because we use x, right, or x as our variable, a lot of times when you multiply with an x, or not with an x, but if you write down the multiplication sign, it looks like an x. So one thing we do sometimes is instead of putting multiplication sign, we put a raised dot, which I know looks like a decimal, but we do that sometimes to show multiplication. So if you see this 10 times 10.10, that means 10 times 10. So just kind of a neat little thing there. So let's go through the example here on the note. And the first question is, how many passwords can you make? And they're using letters here. So just note here that sometimes you're allowed to have, like I said, sometimes restrictions, sometimes not. So for letters, if there's a 5-letter password, you have 26 options, 26 options, 26, and you just multiply them across. So you get this number here, right? So 26 times 26 times 26 times 26, fill those slots. If there's no repetition, then there's 26 options for the first letter, and then 25, because one's gone, one letter's gone, so you're stuck with 25, then 24 for the third, then 23, and then 22. Okay. Note, it doesn't matter which way you fill these in. It'll turn out to be the same number, right? So if I had started with the last number first, so I'm coming with the password, I'm going to start with the last number first, I would have 26 options for this. So this would be 26. And then my next slot would be 25, then 24, then 23, and then 22. It's always going to be the same numbers. They might not be in the same order, but it won't matter because when you multiply them, you'll end up with the same product, right? So that's how you get this number here, 7 million, blah, 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 blah. Okay, so the number itself isn't as important as how you get it. Okay, what's the probability that the password will be written without vowels? So if we're allowed repetition, you take the 5 vowels out, and then you have 21 options for this letter slot, 21 options, 21, 21, 21. So to get probability, remember when we do probability of any sort, what you're going to do is you need a fraction, right? And the fraction is going to have on top the numerator, and on the bottom, the denominator, right? That's how fractions work. And on the top, what I like to call it is the number of success, or NA. So we have NA on top, and on the bottom is NS, or the total number. So I always think of this as success. Okay, you can't read my writing, but that says success. And on the bottom, it says total. So in this case here, we had total was 26 times 26 times 26 times 26 times 26 times 26, right? That was what we got in A. And on top, it was 21 times 21 times 21 times 21, 21. So you have to count properly first, and then probability questions aren't difficult. You just have to count twice. You have to count the success and the total. So that's how you get that answer here. So the success is the 4 million number, and the total is the 11 million, and then you just divide the two to get 34%. Okay, so that's how you get the probability. If you're going to look at the word match, but we have the word match, and we're asked how many ways can we put them in order. You have five. There are 5 letters, so 5 options for the first spot, right? M-A-T-C-H. You choose one of them. Now I'm left with 4. So if I choose the C, I have M-A-T-H, which spells math, by the way. So 4 options, and then 3, then 2, then 1. Okay. What's the probability that the password starts with M and ends with H? So again, you're going to look at success over total. Your total is going to be the 120. The total number of ways to order the letters is 120. Success is going to be a word that starts with M and ends with H. So we can go through these. If we want to go through them, we could probably actually count them all, right? So these end, so I have my slots, and I'm going to start with M and end with H. So they go there, and then you have A, T, and C go in some order, okay? So if you were going to order these A, T, and C, you could have A, T, C, you could have A, C, T, you could have T, A, C. You can go through this and count them all. There's not that many, right? So if you're orderly about it, cat there, you have 6 of them, right? So you can have 6, which is 3 factorial. So you have 3 options, 2 options, 1 option, right? But if you're going to use the slot method, which is just the easiest way to do it, instead of trying to count, what you ask yourself is this. If I have the letters M, A, T, C, and H, and I'm going to put M here and H there, you start with the restrictions when you do the counting. So you ask yourself, how many options do I have for the first letter? And if M is going there, I just have the 1 letter. Okay, I have the 1 option. So M is gone. It's going in the first spot. How many options do I have for the last letter? Well, I'm saying that it starts with H, so I only have the 1 option. And I know that some of you probably won't just ignore this because you'll say, oh, I'll just deal with the middle letters. I think it's easier to put those ones, to write the slots out, right? And then fill the slots. 1 goes here, 1 goes there, and then you have the middle slots here, and then it keeps track of things, right? Then if I have H gone and M gone, I have 3 options for this spot, right? So if I choose one of the letters, it doesn't matter. Let's say I choose the T, put it there. I'm left with 2 letters, A and C. Once I choose that, I'm left with 1 letter. And then I'm going to multiply these across. And I get 1 times 3 times 2 times 1, which is 6, which is what our numerator was in the slideshow here. So 6 is the top. That's the number of successes. The total is 120. That's 5%. Okay, so there's that. There's a quick question here about a raffle, a class raffle. Okay, again, you want total over success. Your 3 friends, you want to know the probability that your 3 friends finish first, second, third. So success is your friends finishing first, second, and third. You have 3 options for first, 2 options for second, 1 for third, or the other way around, right? If you choose third place first, you're going to have 3 options here for who comes third, then 2 options for second, 1 for first. Anyway, when you multiply them, you'll end up with 6 again. On the bottom, you have to figure out the total number of ways that people can be chosen. Note, we're going to assume that in something like this, you can't win 2. Like if you're in a competition, you can't win first and second, right? So there's no repetition allowed. When you're ordering the students for first, second, third, you choose the first place winner is chosen. 20 options for that. That guy's gone. Now I have 19 options. Once that's gone, I have 18 options. That's how I get the denominator. That's the 1140. That's this times this times this is 6840. When you divide 6 by 6,840, you end up with a tiny number here, less than 8%. Or sorry, less than 0.08%. Okay, tiny probability. I'll continue with this. I don't want to make the video too long, so I'll stop after this. The last part here is when you have cases. So when there are cases that qualify as success, you have to add the number of cases together. So for example, in this case here, in this situation here, what you're trying to do is figure out the number of ways the letters A and O can be together if you randomly assign the letters in factor. So you take these letters and you put them in order. There's 6, 5, 4, 3, 2, 1 ways to put those letters in order with no restrictions. So that's going to be your denominator. That's NS. And success in this case is going to be any situation where A and O are together. So one way to do that is to go through this and say, let's put A and O in the first position, okay? So they can go first and second, okay? And then what you do is you have to fill these slots in. So A could be first or O could be first. So I have two options for the first slot and then one option for the second slot. Okay. So I'm dealing with the restrictions first. Vowels first, right? 2 times 1. Two options for the first letter, A or O. Once that's gone, the A is chosen or the O is chosen, then the other one's left over. At that point, I have to line the non-vowels, okay? F, C, T, and R. Four options for the third spot. Then once I chose that, 3 options, 2 options, 1 option. You're going to multiply this whole thing together and get 48. And then what you do is you go through the different cases. A and O can be in the first 2 spots. A and O could also be in the second and third spot. Okay, so you can look at that situation too, and then you figure this out. This is also 48. A and O could be in the third and fourth spot. A and O could also be in the fourth and fifth spot, and they can also be in this spot here. So what you're doing here is you have different cases, and when there are different cases, what you do is you don't multiply these together. You have 48 and 48 and 48 and 48. You don't multiply the 48s, you add them together. So you look at the situation where this happens, and that happens, and this happens, and that happens, and you add them together. They're all successful. They're all situations where you have success. You add the 48s together. That's how you get 240. That's your numerator. 720 is this number here, your denominator, and your probability is 1/3 or 33%. I'm not a huge proponent of lowest case fractions. When we talk percentages, when we talk about probabilities, percentages are great, and then also decimals are the best. So I prefer an answer of 240 divided by 720, 0.33 or 33%. 1/3 is great, but I think we talk better, we can relate to each other better when we talk percentages or decimals, okay? Because fractions can be a little inconsistent. Okay, so that's it. I'm going to go on to the next one in the next video. Hopefully that makes sense. Send me an email if you have any questions.